A piecewise function, we said yesterday, is pieces of different functions graphed together on the same graph. So the first thing we're going to do is look at an example of a piecewise function. Okay? Here we go. Here we might go. Where are you at? Oh, there it is. Okay. Graph f of x equals, and then you'll notice we have this little brace here, and then you've got more than one line going on. X minus 4 if x is less than 2 and 1 if x is greater than or equal to 2. Okay, so what you have here is basically two functions in one. And this tells us on which part of the x-axis does it change. Okay? On the x-axis, as long as x is less than 2, this is the function that's showing up. Whenever x is equal to 2 or greater than 2, it's a new function. All right? So now what we've got to do is identify exactly what kind of function it is. Well, both of these are lines. Because f of x is the same thing as what? Y. So this is y equals x minus 4. What form of a line is that in? Is that point slope standard form or slope intercept form? Slope intercept form. Okay, so the first thing I'm going to do is separate the two functions so that it's clearer for me to see what I'm looking at. So this first one is y equals, and I'm going to put a 1, x minus 4. That is the equation of a line in slope intercept form. The slope is equal to 1 over 1, and the y-intercept is equal to negative 4. Does everybody agree with that? Okay. This second function is y equals 1. Now, we went over this in detail yesterday. Y equals 1 is a what? A horizontal line going through the y-axis at 1. All right, now we've got to graph the two things, and I'm going to show you how to do it. Okay? Let's extend the page. No, really. Let's extend the page. No, really. Go back. Okay, whatever. If you are gone, I will scream. Ah! Okay. This is how you're going to go about graphing these things. On the same graph, Ken, can you put your water away, please? On the same graph, you are going to very lightly graph both of these lines. Very, very lightly. So, here we have a y-intercept of negative 4. So we start on the y-axis at negative 4, and from that point, our slope tells us to move what? Up 1 and to the right 1. So I'm going to go up 1 and to the right 1. Now very lightly, which I can't do it lightly, but very lightly on your paper you're going to graph this line. Okay? And it needs to actually go through the point. Alright? The second line we said is a horizontal line going through the y-axis at positive 1. So I'm going to very lightly on my paper, on your paper, graph that line. Now, where does the piecewise stuff come in? This is where it comes in. It said that this is the function that exists as long as x is smaller than 2. And then once x gets to 2, this is the function that exists. So I'm going to show myself where does the break occur. Okay? The break occurs right there where x is 2. Now, which function exists? Meaning that the function breaks and starts off as a new function. Okay? This function exists everywhere to the left of this dotted line. And less than 2. So when we did inequalities, we used circles, either open or closed, to show a stopping point. Well, if this function exists as long as x is less than 2, right here, where it meets this broken line, I'm going to put a circle. What kind of circle? An open circle, because this is the function that exists as long as it's less than 2. And once it equals 2, a new function is created and exists everywhere bigger than 2. So what you're going to do now is, because you're going to have these two lines lightly drawn on your paper, you're going to darken the part that exists less than 2 and greater than or equal to 2. And if you did it very, very lightly, you really should not be able to see these parts anymore. Yes, we're going to do several. The dotted line is to show me where is this function changing. Where do I stop one function and start another? And if you remember from the original problem that my board erased, it said that this function exists if x is less than 2. And this one exists if x is greater than or equal to 2. So 2 on the x-axis is where the split happens. So I'm identifying where the split is. So what I'm trying to tell you is you're going to very lightly graph the lines, and when you identify the split, now all you have to do is decide which one gets the open circle and which one gets the closed circle, and just darken the right side, the correct directions that they go in. Okay? But this was the graph of that piecewise function. Excuse me. All right? Let's look at another one. We'll do the even ones on page 94 because you're going to do the odds tonight. Okay, so we'll look at number 38. 38 is an example of a piecewise function.
30.
No, it's number 38, page 94.
My bad.
38 says f of x